Okay, for this next round of troubleshooting with regards to the laser flare on the Form1, I thought it'd be a little bit more interesting to just put into a little bit of context of one of my projects, one of my personal projects I'm working on. Okay, so this is just a micro EDF Orca Hunter, and I'm using a method of casting urethane foam for the parts. Alright, so I'm at the point where I want to try and cast this fuselage section half in urethane foam, and I was hoping to use the Form1 SLA printer to print the molds. So we got like a positive and negative molds because they're quite detailed parts, these. So what I'll do, what I've basically done, I'll just take you through my workflow so you can see what I'm looking for, looking to achieve. So this is basically the part. At the moment it's a lot longer than the Form1. We're at what, 512 millimeters in length, so it's going to have to be split up into parts. So the mold will have to split up in parts, exactly the same way basically as what I did with the FFM printer when I printed the wing molds in ABS. So yeah, so basically I took the final part and created a core, which is this one here, core for the mold, and a cavity for the mold. So basically what we got is your core here, your cavity here, and this is what we get. This is what is going to come out the mold after it's been cast. So then I need to look at splitting the molds up so we can print them within the Formlabs Form1 build volume. So we collapse that down, and I'll just show you how I'm intending to split it. So we show that sketch. So that's what we're looking at basically. That's how many parts we're looking at. So we've got one part there, sorry, we have one in the top, 2, 3, 4, 5 sections to both the cavity and the core part of the mold to get printed. So as a test piece, what I decided to do was just print the back end of the fuselage, and sort of incorporates part of the vertical stabilizer, and this is where we're at. So look at that. So this is the part that we're looking to cast. So this is the section that we're looking to cast with the molds. So going forward, I then created the mold. So I created first the core part of the mold, which is this part here, and this is the first part I printed. And I basically printed it as such. A bit of a rush. What I ideally thought of doing was just hollow it out a bit to relieve some of this material. It's not really required, but being it was the first sort of attempt at this sort of thing, I thought I'd leave it and see how it prints. And the intention was to print this at 0.2 millimeter layer heights, which is the sort of drafting, the new drafting layer height with the Form1. Main reason being, no one's going to see the inside surfaces, so as long as they print well, hold the form, and don't create any keying areas for the cast piece to get past, it'd be alright. So I printed that, and then learning from that part there, I then thought, no, when I do the core bit, which is this part here, what I need to do, ideally do, is shell it out a bit. So I spent a little bit more time on it, shelled it out, put a flange around to keep it stiff, and this printed, I mean, from a design point of view, it's perfect. I might even be able to reduce the thickness of the shell from 5mm down to, I think it's 3mm. Yeah, this is 3mm at the moment, thick. So the flange is 3mm, and this and the main surfaces are 5mm, I think, at the moment, but I think I could reduce those all down to 3mm, so which would in itself save both material, time as well. And yeah, so from design perspective, that this has worked really, really well. So the concept has worked really well, but because of the laser flare issues on the printer, which I'll discuss next, you'll see that wasn't very successful. So if we have a look at what we did with Preform, and then I'll discuss my reasoning for orientating the parts the way I orientated them on the build platform. Okay, so this is the core part of the mold on the Form1 Preform software. You see I've orientated it with the longer supports towards the hinge side, which is always good practice. I know that this surface isn't going to be as good, the rearward surface isn't going to be as good as this front surface because of the laser flare, but I wasn't too worried about that because this part of this surface is going to be on the inside of the plane, so no one's going to see it, so it doesn't have to be technically silky smooth. To print it the other way around, it would also mean having all the supports. Yeah, I could have rotated that, I think. Let's have a look at the top. If I rotated that round, yeah, which is what I did on the cavity part, to make sure that the surface, I had a good surface. So anyway, so that's the orientation. I printed at 0.2 millimeters. Ignore that. I was actually at 0.2. Yeah, it took about 6 hours to print, which is about is what it took. So it adhered to the build platform fine. Really bad surface on the rear, which I'll explain later with the actual printed part. But so yeah, anyway, I'm going on a bit. So that's basically the reason why I orientated the way I orientated it. So I wasn't standing vertically up. I tilted it as much as I dared, and that's basically what we ended up with. Okay, so here we're looking at how I orientated the cavity part of the mold, and as you can see, I took a chance because I really needed this surface to be as good as possible. Now this is going to be this shown surface that people are going to see, or customers are going to see. So I wasn't too worried about this surface at the back, but I was worried about this surface at the front. So the only way I can orientate that to get to work would be to have the long supports away from the hinge, which isn't ideal. So if we have a look at our orientation here, I'm not sure why that happened. There we go. Okay, so we got the front, yeah, and then we got our hinge side, and then we got our long supports. So it's not as bad. You got some supports near the thing, but ideally you'd want all these long supports here along this hinge side. But like I say, I've had to orientate it this way because I wanted the worst surface that I knew was going to be caused by the laser flare to be on the part of the mold that wasn't really important. And you'll see from the examples in a bit that that's exactly what's happened. Okay, so first we'll look at the core part of the mold. Now this is the part that I printed on the Form1, and we printed this at the new 0.2 millimeter layer resolution, layer height. So the reasons for printing at 0.2 was because it's the core, the surface finish doesn't need to be as good as the surface finish for the cavity, because the cavity surface finish, the external surface finish, is what the customer will see. So we're not too worried about the internals, as long as it is a good representation of the solid, and we don't have any binding issues when we are trying to pull the cast part out of the mold. So as you can see here, I am disappointed in the actual resolution of the layer height. I'm confident that I could get a better print with the FFM printer. Even at 0.2 I'll get a better surface quality, and I think again part of that is I'm almost certain it is just due to the part cured resin interrupting the build and affecting the surface quality of the finish. Now when it came out of the when it actually came out of the printer, it wasn't too much. There was quite a bit of flaking, but there wasn't too much. It was, you know, within reason. And when I'm talking about flaking, it's like, almost imagine a fungi on a tree. You know, you have those sort of mushrooms or fungi that grow off a tree, that sort of grow off. That's why I'm calling or terming flaking. But I mean, I'm not really too worried about that because that actually washed off. But you can see the actual striations in the part are quite extreme, and I think that is because this part cured resin being cured, so it's not actually printing a crisp line. It's printing quite a fudgy, smudgy line. And an area I actually, just with my nail when it came out, with the surface was quite soft, so I could actually scratch through the surface a bit, and then it would get hard, so I could actually scratch off quite a lot of that resin. Now, I'm hesitant in doing that because are you actually reducing the thickness of your material, or is it because the laser flare? So, you know, it really wasn't a successful print, and you can see all these little drips and drabs of bits inside the resin, and that's all. This is all just part cured resin. The end bit here, this bit here, where it looks quite poor. Actually, it was because the resin in the resin tray actually ran down really low. So yeah, just ignore all that bit because we can say that's my error, nothing to do with the printer. But everything from you know, where that obvious error is there up is as the Form1's printing. So you know, I'm not really hugely impressed with the print quality on the 0.2 layer, and I think that's because of the laser flare. Obviously the printer is going to be, the print speed or the tool path is going to be slower, or the intensity of the laser is going to be brighter to accommodate the additional thickness. Now Form lamps have the 0.2 layer height as a like a what are they calling it? Prototyping sort of speed. But even prototyping speed, I know for certain I could print a lot better with a MakerBot, with my modified MakerBot at 0.2 resolution. At 0.1 resolution, you know, it'll be miles ahead of this. So that wasn't that. You know, I was a bit disappointed with that. But in saying that, again, this is going to be proof of concept as well. So I'm hoping to be able to use this part. From a design point of view, obviously, you know, because I just wanted something quick to get out, so I didn't actually reduce the thickness. I could have actually taken some thickness out of the mould. I wasn't really sure how strong this was going to be, but yeah, so this is really strong. No issues mechanically with it. With this 5mm, I've had a 5mm, like a rule of 5mm thickness, skin thickness, wall thickness, and it's all stayed reasonably straight. This edge here, which is the edge I was facing that got printed first, is very wavy, and again that might just be because the way I orientated in the build plate, you know. So I had this face facing forward because this is going to be my good face, and the back face was this face here, which actually, to me, it looks like it's almost printed better than the. Yeah. To me, it looks. Actually, did I? It might have actually been that way around on the build plate when I took it off, with the long. That's right, with the long supports up the front towards the hinge mechanism on the printer. But yeah, I'm hoping I can tidy this up enough just to do a proof of concept on it. But as you can see, the surface quality is very poor. Yeah, so that's the core part. So learning from that was the first thing I printed. So learning from this, I then redesigned the cavity part and shelled, you know, spent some time actually shelled it out. And this is what we end up with, unfortunately, which is very disappointing because I thought I got rid of all this. Yeah, so here we go again. Basically, this is the rear surface facing the rear of the print. Yeah. And awful surface. Structurally, it's going to be very poor, and this is all part cured, caused by the part cured resin getting trapped in the print. So this took up a lot of the build plate, then the build volume in the printer. So it was a good test on that sense of things. I had to print this with the long supports at the back, facing the back of the printer, because that's where I wanted the bad surface to be. I don't want the good surface, and this surface is actually, doesn't actually look like it, but the actual surface is a lot better. It's smooth to the touch. You get the striations from the layer heights, obviously, but it's smooth to the touch. This side is awful. Yeah, it's like, it really is awful. I'll take some detailed photographs of that, but I think it's quite evident from that where the problem is. So this was again printed inside the house. The room wouldn't have dropped down below 16, 17 degrees. So probably between 17 and 20 degrees. That's what the room's been at for the last week or so. So we can't look at this and go, oh, this is caused by, this all here is caused by the resin being too cold. And even setting this print up, I did jump through hoops to get it to work and get it orientated. So I wasn't able to orientate this as the way I wanted it to, which would be to have this face facing the rear with the long supports up the front towards the hinge. But it was a successful print in the end in that respects, in the orientation respects, apart from this awful what would we call that? I don't know. I don't know what you want to call this. Bubbles, parquet resin inside there, whatever you want to call it. So the resin tray, I filled the resin tray up 3 times. So it's always maximum level majority of the time in the printing, and you can see there that it really is a not a good print. Being as the important surface is good, relatively good. I'm hoping I can just sand this down and flat it off. And this was printed at 0.05 because I needed, the whole point of doing it with the SLA is to get a better surface than the FFM type printed, and it should work out better, but unfortunately I'm pretty sure I could print out probably 0.1 with the FFM printer and get that sort of quality on the surface, on this surface. So I think it's going to work. I think it's good enough for me to do a proof of concept with it. So you got the core and the cavity part of the molds there. And the reason why I've done it purposely in clear is I'm really keen to be able to see the casting material as I'm casting it. So the urethane foam, the white urethane foam, I'm keen to actually see it expand as I'm casting it and fill the voids, just to give me a better understanding, so I'm not working blind all the time with these molds, which is, I think, would be a real win if we can get it to work, if I can get it to work, which I think it will do, as long as my release agents and the previous workflow I used with the ABS molds is the same, which I expect it will be. But I mean, it actually fits together quite nicely. I haven't cleaned it up at all. I need to do some work on this face here, but it actually clamps together quite well. Strength is nice, so it's just a case of a lot of manual handwork now to get this to a point where I can test, do a proof of concept test with it. Okay, so I don't think I need to say more really. Yeah, just disappointed. Really disappointed with this. After I printed that at 0.2, I thought, oh, maybe if I could get even, at 0.05, sorry, and get something clear. And then I saw this, and there's not much more I can do orientation-wise to make it kinder, because this was, I'll show you on the Preform how this was laid out. I don't think there's very much I could actually do that wise to improve surface quality, and this is all laser flare. The resin was strained prior, the mirrors were all cleaned and checked, the tank was all cleaned and checked. Yeah, so really disappointed with that. But hopefully there's enough there that I can work with it and just do a proof of concept for this this new mold system I'm working on. Okay, great. Thanks for watching. And when I get a chance, I'll do some more detailed photographs of the perhaps the finished part prior to mold testing. Okay, cheers.